Good afternoon, students. Last time I had told you about diffraction. What is diffraction? When light falls on a very small opening, the size of the opening should be of the order of the wavelength of the light. Then light from the corners bends. This incident is called diffraction of light. Now come diffraction due to single slit in the laboratory. This is source of light S having only single wavelength, that is called monochromatic light. It falls on the wavefront, falls on the lens L1. This is kept at 2f distance from this lens. Then these wavelengths are parallel and wavefront is moving in the forward direction. This is a small opening, slit AB. The width of the slit is A. The size of the slit is of the order of the wavelength of light. Now again there is another lens L2. Here wavelengths are moving, or wavefronts are moving in the forward direction. When they are reaching from B2.0 and A2.0, they are traveling equal distance from this side A to C as well as B to C. They are traveling equal distance. So at this point there will be bright spot. That is called central maxima. This central maxima will be surrounded by number of bright and dark fringes, circles, which as we will move away from the center, the intensity of light goes on decreasing. Now secondary wavelengths, let's suppose now they are moving at an angle theta. When they are moving at an angle theta, secondary wavelengths, the theta angle is this one, theta angle is the same here, and theta angle is here. Draw the perpendicular. Now the wave from A to P and B to P, they are traveling unequal distance. Unequal distance. Is the unequal distance? Draw perpendicular A to N. This is right angle. If Pn distance is traveled by this side Cn is both. So here intensity of light will be bright and dark depending how much distance it is traveled by Pn. Pn is equal to Pn. You have to convert to that will be equal to A sin theta. Pn will be A sin theta. Now with the help of this, we can come to the straight wave on the x. How much distance this one? We can calculate the value x is equal to d lambda upon A. What is A? Width of the slit, lambda wavelength of the light, the distance from slit to screen. This is the screen. Now central maxima, if you want to calculate width of central maxima, 2x is equal to 2d lambda upon A. Now d is changed by the f. So 2f lambda upon A. What is f? F is the focal length of the lens. Lambda wavelength of the light. A width of the slit. 2x width of central maxima. That central maxima will be of this type. Central maxima will be of this shape. That we will discuss later on in the next video. Thank you.